Hi friends, today let's start with network theory revision. So the first topic here is active and passive elements. So active elements and passive elements are one of the most important questions which are asked in ECET. So if you remember elements like resistor, inductor and capacitor, these elements absorb and dissipate or in fact waste electrical energy. However, if you consider electronic devices like BJT or MOSFET, these elements energize, give out or drive electrical energy. So this is one important classification. So these three elements are passive elements and these two elements are active elements. Coming back to the network technology related keywords, so we have to remember some keywords, namely node, which is a point of interconnection or junction between two or more components. Also, we have to know what exactly is a branch. So this is an elemental connection between two nodes. So many times there is a chance of asking what exactly is a mesh. A mesh is a closed path basically, and whereas a loop is also all possible closed paths. Now one of the most important topic in network theory is Ohm's law. So at constant temperature, Ohm's law is represented in two different forms, namely first form is J is equal to sigma E and V is equal to IR. Simply I can say J is proportional to E and V is proportional to I, where the proportional constant is R and sigma is the proportionality constant. Here J is the current density, rho, which is 1 by sigma, is called resistivity, and also we have another formula, R is equal to rho L by A, which means where L is the length of the conductor, A is the area of the conductor and rho is the resistivity. So the symbol of resistance is like this. So we also have to remember conductance, whose value is given by G is equal to 1 by R. So to apply Ohm's law, generally when a current I passes through a resistance, so a voltage V will be generated. So the next important topic is short circuit and open circuit. So in a short circuit, the basic important point a student has to remember is voltage across the terminals is 0. So V is simply 0 and the value of current can be anything because R is 0. Whereas in open circuit, current is 0. So in short circuit voltage 0, in open circuit current is 0. So this translates to resistance being infinity. Now let's know about the value of power in a resistor. So power is product of voltage into current, or I can simply say V square by R or I square into R. So we have learned about these two laws very much in our school level. So what exactly is KCL? It is an algebraic sum of currents at any instant leaving a junction or node in a network is 0. So we can also simply say that current entering is equal to current leaving, specifically at node. So it can be represented by sigma summation of all currents is equal to 0. So if I take this node, so if current I3 and they have different currents I1, I2, I5, so I can simply say I1 plus I3 plus I5 is equal to I2 plus I4. So current entering is equal to current leaving. Now let's know about KVL. So in this algebraic sum of voltages around any closed path within a loop or a network is 0. So simply I can write sigma Vn of t is equal to 0, or I can also write it as the dropped voltage is equal to the rise in voltage. So there is a small network like this. If there is a voltage V, so there if a current passes through this, so plus minus V1 plus minus V2, so V is V1 plus V2. Now let's know about series resistance or voltage division. So if there is a small network like this, so you have R1 and R2 voltage. So since both the elements are in series, so the same current passes through the resistance R1 and R2. So if I apply KVL here, I will be getting, so this is voltage V. So if we start here, minus V plus I into R1 plus I into R2 is equal to 0. So therefore V is equal to I of R1 plus R2, or I can simply write I is equal to V by R1 plus R2. Now if I calculate V1, this voltage, so V1 is simply I into R1, or I can write R1 into R1 by R1 plus R2 into V. Similarly, we will get V2 as I into R2, which is R2 divided by R1 plus R2 into V. So the next concept is current division or parallel resistance. So if there is a current source I and two resistors R1 and R2 which are parallel, if the current is to be divided, so in this case R equivalent, since all the elements are in parallel, so R equivalent is equal to 1 by R1 plus 1 by R2, and I1 is I into the opposite resistance R2 divided by R1 plus R2. If I need I2, it will be I into R1 by R1 plus R. Now many times in exam we get the concept of star to delta and delta to star. So student has to remember this notation: R1, R2, R3, RC, RB, RA. So I can simply write RA, which means this particular element. I'll simply take two resistors at a time, which is R1, R2, and then symmetry based on the symmetry R1, R2 into R2, R3 into R3, R1 divided by the exact resistance at this particular branch. Because I'm calculating RA, it will be R1. Now similarly, let's take RB. So this is RB, and the opposite resistance, if you keep this particular elements in the so this is your star network, this is your delta network, so it is summation of R1, R2 divided by the exact opposite of RB is R2. Similarly, RC will be summation of R1, R2 divided by R3. Now to calculate the delta, so now I got the values of given R1, R2, R3, we can calculate RA, RB, RC. Now if RA, RB, RC are given, the value of R1 will be simply, now also observe this, R1 is here. So here, so the value, the R1 branch will be coming somewhere like here. So it is nothing but multiplication of its diagonal junction RC into RB divided by sum of RA plus RB plus RC. Now if I need to calculate the value of R2, it is nothing but this junction, two resistors are there. So RC into RA divided by sum of RB. So try to remember these formulas, they will be very much useful during solving multiple choice questions. So next, sources. So we have independent voltage source and current source and dependent voltage source and current source. So independent voltage source will maintain a specific voltage across the terminals, and the voltage is not dependent on current flowing through it. Similarly, an independent current source will be maintaining a minimum current value, and the current value will not depend upon the voltage. Now coming to dependent voltage sources, so we have four classifications, which is voltage controlled voltage source, current controlled voltage source, voltage controlled current source, and current controlled current source. So only the names are to be remembered in the level of diploma. So I can simply write V is sometimes A into Vx, or V is A into Ix. Here I is equal to A into Vx, or I is equal to A into Ix. So the dependency is something like Y is equal to Mx plus C. So if this is Y axis and this is X axis, so a straight line, as X varies, Y will be varying. The same concept comes here also. Now let's get introduced to our next hero, who is capacitor. So capacitor is with the same simple concept of two conducting plates separated by non-conducting material. So I can have a simple formula: C is equal to epsilon A by D, which is a very important formula. And also we have to remember the charge stored in this capacitor is Q is equal to Cv, where C is the capacitance, V is the potential difference between the plates, and I have epsilon is permittivity of the medium, and D is the distance between the plates, and A is the area of the plates. Also, the notation of the capacitor will be something like this: plus minus V of t. If the value of the capacitor is C, I can write I of t. So it will be governing the equation I is equal to dq by dt, and I is equal to C dvc by dt. So also remember the sign convention. Next, what is the energy stored in a capacitor? So I can simply remember E is half Cv square or Q square by 2C or half Q into V. So these are the three equations which will be the energy stored in a capacitor. Now coming to the ideal properties of a capacitor. So the voltage across a capacitor cannot be changed instantaneously, or I can simply say it is constant. So you imagine a battery. Can you immediately remove all the charge from it? No, there is a process of discharging and then charging. So similarly, the student has to remember this. So capacitor, so the current can be zero and then it acts as an open circuit. So the voltage across a capacitor must be continuous in nature. If it is discontinuous, then I is infinity. So voltage across a capacitor cannot be changing instantaneously. So a capacitor would never dissipate energy, and it only stores energy. Now capacitors in series, we will be having C equivalent. If there are capacitors C1, C2 and C3, C equivalent will be something like 1 by C1 plus 1 by C2 is 1 by C3. And if they are in parallel, we will be getting expression something like C equivalent is C1 plus C2 plus C3. Now coming back to inductor. So it is a two terminal element with n turns, and we'll be having formula of inductor as L is equal to mu naught ur into n square A by L. So you will also have a current voltage relationship, which is V of t is equal to L into di by dt. So this is one important equation. So the energy stored is half Li square. So when you have three inductors L1, L2, L3 in series, you will be having something like L1 plus L2 plus L3 will be your L equivalent resistance, and when they are parallel, you will be having something like L equivalent is 1 by L is equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3.